showing all the sponsors. Denso, Toyota, Mobis, and many others.
I recommend many of these other components here, like the Git integration, but that's something that you can install later. For today, we do need the NuGet package manager.
And NuGet, right?
Yes, yeah, you need that one. And you also need to make sure that you have the .NET desktop development selected. The only issue is now this will have to download those. Yes?
F15.
Those will be all you need to really know. They'll look a little different, but they'll work pretty much the same way.
And I think some of them came to Robot C also.
All right, so
Yeah.
have you done
Yes,
Robot
yeah.
C as well? Robot C might be a little bit closer. C# is a lot like C or C++. It's not so much like Python, but again, these same things are there. And by not so much like Python, I mean in how it looks. Where Python, you don't have a lot of braces around or parentheses. In C#, you do have those things because it's a more C-style language. So for this, just a quick example, we will start a new project in Visual Studio. I have Visual Studio 2015 on this laptop because that's what the LTU students get. There's only one slight tweak we'll need to make for 2017. So, I clicked New Project. Now, mine is already open to C# Windows because that's the last new project I made. If yours is not open to that, although most of you with 2017, your only option should be C#. Your menu may look slightly different from this. You should be able to, though, find Visual C#, Windows. You may see something that says, like, Classic in it. So here, Classic Desktop is the option I have. I'm going to click Console Application. And I'm going to call this, I'm giving it a name. I'm just going to call it Hello C# Workshop because I already have a few projects. I have Hello C# and Hello C# 1 and 2 from my classes. So I told it to create a new console application project. This is going to make something that does not have a graphical user interface. It's like what you've probably done with Python, where you have something where you can display text, something where you can type text in, but it's not going to have any fancy graphical stuff going on here. Later we'll get to that. We'll actually do an example. We'll build a graphical user interface for the EmguCV project. But first, I just want to run over some stuff real quick with C#. So here I have a C# project open now. This is my main file. So again, if you're coming from Python, your main file by default is just empty. You don't, yes?
Do we have to go into this one?
Sorry, what was that?
Do we have to go into this, like?
It should open automatically
Oh, okay.
when you create a new project. So in here, there's a function. If you've used Java before, it's a few hands for Java. This might look a little familiar. Static void main. Well, and this is the same thing as the main function in Java, or the main function in C or C++. It's a function that is running when your program starts. Now, technically, you can change it to different static void functions. But for this example, by default, it will be this main function. So any code we put in here will run. So, and well, this will work. I have a plugin installed which adds, so at the top of the file here, there are these using statements. If you've used Python or C++, you probably have seen things that say like include or import. Well, actually, all programming languages typically have something like this for including libraries. this is the C# version of that. So we're saying what libraries we're using in this program. So in this case, and I'm going to start putting in some of the code. If you have something that is not in your program, you don't have the using statement, you can see it's showing up as red. It's saying, I don't know what debug is. Well, there's an easy way to fix that. Down beneath it, a little light bulb should show up. It may be on the left side of your screen. If you click on it, here I get the option to add a using statement. So mine says using system.diagnostics. Well, that's the library that this class is in. So I'm just going to do a quick hello world example here, but we'll do a few other things that are very useful. Some things that if you've used C# will be new, actually. One of them will may be new. So with this example program, I'll give you a second if you're still typing there. Yes?
Do we want the console application?
Yes, you only need a console application. So I took that hello world line. I'm going to get rid of the hello world part. And now I've put that into this loop. So this loop has a variable. If you come from Python, this is like a for I in range 0 to 10. It's a loop like that. This is saying we have a loop that this is the code that runs before the loop in I equals 0. That makes the loop variable. The loop continues while I is less than 10. Then every cycle of the loop, I will increase by 1. That's I++. So if I run this, it goes through all the numbers 0 through 9, because it ends when I is equal to 10. And it adds them together and finds what the sum of it and itself is. So this is just a quick example of, we can do loops in this. If statements, I want to cover this for you guys who came from Python, because these do look a bit different. So here, I'm going to have it only output the even numbers. So here I have if I modulus 2 equals 0, that means the number is even, it is a multiple of 2. Then it will output that line of code. So here, now it only outputs the even numbers. So that's just an example of what a loop looks like in C# and what an if statement looks like in C#. C# also has a lot of very powerful tools for containers, which are like lists in Python. And actually, they're called lists in C# as well. But we have, we have a lot of cool tools. There's this whole thing called link that we have that we can do some very powerful things with. However, we won't need to get into that right now, but I do strongly recommend learning a lot of the things this language is capable of. It can really help you solve problems. So I'm going to close this sample project we had. You should do the same thing just so you don't get lost when we start for going through to set up a sample project for EmGu. Step 1 obviously is Open Visual Studio. So we'll have to create a new project. Now this time, previously I'd used the console application. This time you'll want the Windows Forms application. So I just created a Windows Forms application. There are other options. This is sort of an older GUI framework. You can tell because the window that it popped up with here, this is actually an interface designer. But you can see that window looks like an older version of Windows. That's because this is an older framework to use for making user interfaces. There are 2 newer frameworks that you can use. However, this would work fine with any of those. I just use this because it's the quickest to get something together in. So the next step we'll have to do is to add EmGu to our project. So it's really nice, yes?
So, where's the Windows thing because it's not showing up.
Windows Form.
Yeah, Windows Forms, or it might say WinForms,
I
or...
think they did not, when they are trying to install, I saw that they did not install. I think most of them
Oh, wait.
install. Yeah, when they install, there is an option to install.
Not have it, click on
This is
View,
what I'm doing. There is a
and
Windows-
click on Solution Explorer, and then you'll have it.
Windows platform
Oh,
development, right?
And then what do we do?
Okay. So the next step is to actually add EmGu. Right click on here where it says References. Then there's an option that says Manage NuGet Packages, and it has a little picture of like a birthday present, basically.
Not now.
If you click on that, well, it should open a window like this that doesn't show anything. That'll say No Packages Found. That's because we are in the Installed pane. This is for things that are already in our project. We didn't add anything to our project yet. So if you click on Browse, so this might take a second to load, but we have this big list of different things we could add to our project. There's a lot of really cool things available through EmGu, or sorry, through NuGet. We want to, in here, type in EmGu. So if you type EmGu into the search box, you'll get a bunch of options. What we want is the top one, EmguCV. So you can click on it and then click install, or if you mouse over where it says EmguCV, this little thing pops up that you can click here to install it. Either one will work. This other window will pop up asking you if you're sure you want to install the thing you just told it to install. You can just click OK. There's a license agreement that you are going to agree to, assuming you're supposed to read it, but for, I've already been through this, I'm hitting accept. So I already had EmGu downloaded, so it was instantly added to my project. You guys, it might take a little while longer. There should be a window at the bottom here that has some text saying what it's doing. So yours might still be on, well actually, since mine was already on my computer, I don't have it, but it may say that it was trying to download EmGu.
Does it say finished after you're done?
Yes, it does.
Oh, okay.
So yours is done already?
Yeah.
Wow, that's great. Okay, does anyone in here not have that done? Okay, so I will come back there. So, by the way, this PowerPoint will be available to you.
Yeah, it'll be on.
Not just the video, but since I just skipped through a bunch of slides. So this will help you refresh yourself if you need it. So here, we're going to have to go back. So up here, next to these tabs up here, next to the NuGet tab, there should be one that says form1.cs design. This was that window we saw earlier. So you can actually, you can resize this. This is using something called Windows Forms. So I have this clicked on. In the lower right-hand corner, I have a window that says Properties. I can actually change things about this. I can change, so there's one that says Text. That's the title at the top of the window. I'm just changing this as an example. I typed in Hello EmGu. Now the window says Hello EmGu. There's other options we can change, like we can change the background color if we want. So I can make it whatever color I want. I'm going to leave it like it was. And we have all these different things we can do with the window. So what we're going to do is we're going to grab a picture box. Oh, so I sort of stepped ahead. On the left side, there should be something that says Toolbox. So if you click on that, it'll open a window. It's a list of things we can add to our user interface. We want one called a picture box. There's a search bar at the top. Yes?
I can't find toolbox.
If you can't find Toolbox, go under View, and then there should be one down here that says Toolbox. If you click on that, it should add it. So here I'm clicking on Picture Box, and I'm going to click and drag that into my window. And then I'm going to make this a bit bigger. So all these components, by the way, you can give them names. This one right now is just being called Picture Box 1. If you had a very large project, you would want to give it a name like Preview Box or something that says like what it does, because that's good coding practice. Because we're limited for time here, I'm not going to be renaming everything. It saves both of us a few steps. So now we have a window with a picture box. And as an example, I'm going to hit the Start button. And now I have an empty window because we have a picture box with no picture.
Where's the start button?
Like, what do we do after we click toolbox?
Alright, so after you hit Toolbox, search for Picture Box,
Oh, okay.
then drag it into your window. Where's the Start button? The middle here should be, there should be a button with a green triangle that says Start at the top middle of the screen. If you don't have it, hit F5. So the next step, now that we have a window with a picture box in it, is to actually make it do something, because we're not showing any picture in here. For this example, we'll be showing our webcam image, which is what we'll want to use for a robot anyway. So the next step, double click on the top of this window. So don't double click on the picture box, double click on the top of the window. This will jump to this code. Double clicking on that created an event handler. That means some code that runs when a specific condition is met. In this case, when the form loads, this function called form1load will run. See, that's why it's nice to name things that, it's nice to give things names that mean something. That makes the code a lot more readable. So we could have if we have a button that says start the robot, if we have start button click, well, that tells us exactly what that does. It's very readable code. So I added that. The next step is we're not going to use that function yet. We're going to add two variables to our class that we will be using for the next steps. The first one is something called a video capture, and the second one is something called a thread. So I'll talk about these. I'm going to put them in to Visual Studio. They need to be outside of any function. I'm going to pop them down. I'm going to plop them down right here. Each of them has a using line that it will need. So again, if you click on it, it should pop up with this little light bulb that if you click on it, you can see, oh, using this, using system.threading, or here, using EmguCV. So now it turned those green and it's happy with them. However, we're still not using them for anything yet. So the next step, the video capture object, that obviously captures video. It actually can capture video from a file, from a web stream, or a webcam. So also, if you have multiple webcams installed, it can access a specific one of them. It's not limited to only your built-in webcam. So it's a good idea. Do you have a question? Or?
Oh, no.
How did you get to like, I'm still on the design thing, so.
Oh, double click at the very top of it. Yeah, sorry, on the top of the window in the window. Oh, so you're good now?
Yeah.
Yes.
This is nothing to do with this, but can this interface with Mindstorm as well? Only the
Yes,
robots?
well, it depends what you mean by interface with the Mindstorm.
Like right now, you can use the LabVIEW or the Robot C.
There is a way that you can, I believe there is a C# for Mindstorms.
Not sure.
I'm pretty sure there is. I don't know how well developed it's been
Okay.
because I haven't touched anything Lego for most of the last decade actually. But I do know there was one back in the NXT days. So I hope that they were still around for EV3 and the newer stuff. I can't say for sure either way.
Okay.
I do know there is the Java for Mindstorms, so that should still be around. I don't think they would have stopped production on that.
Okay. Okay, that's fine.
Okay, so these 3 lines here are setting up the video capture object and the thread. Now, the display camera or display webcam part in there is still red. That is referring to a function. So a thread is a class that allows us to run a function in the background effectively. Yes. In the background here to display our webcam image. This will also process our webcam image. The reason we do this in a separate thread is because we have a graphical user interface here. We want to have buttons the user can click on, and I should say we're the user technically. We probably want some inputs we can use. If we want to have those, we need to have a way that the program can respond to those. If it's too busy processing the vision to handle processing the user inputs, we're going to have a bad time of trying to actually use the user interface. By putting it in a separate thread, it's running it in the background. The computer is able to do 2 things at once. And actually, your computer is probably doing hundreds of things right now. You may have thousands of threads open. You just don't know it yet. So the next step is this display webcam function. So this function is very straightforward here. While the capture is open, that's while the webcam is still working effectively. It will, and we'll talk about what a mat is and what CV invoke is. Well, actually, we'll talk about CV invoke right now. The mat we'll talk about in a second. We can see it has capture. That was our video capture that gets the webcam image. We're querying a frame from it. That means we're getting a frame from the webcam. We're doing a resize. CV invoke. This comes from OpenCV. This is just saying we're doing a function that is one of the OpenCV functions. There's a lot of them. In this case, it's to resize the image. So we're resizing it to be the same size as our picture box. And then this last line is setting the picture box image to be the bitmap version of the image we got from the camera.
My thing messed up.
Oh, did you delete, did you accidentally make a picture box click event and then delete it?
Yes.
Don't worry. Yeah, so what's happening here? So, you guys who had done some EmGu stuff before we were using the image box, that is still a possibility. However, we're using the picture box just to make things simpler to use. The picture box is just we call it a dumb box. It shows a picture. It doesn't have all the extra features that the EmGu user interface had. You can't zoom into it. You can't apply effects to it. But it shows the image, and that's much faster for us to set up.
Yeah. Then
So if you run this code, now I'm standing up, so it's a little cut off, but you can see that it's showing my webcam right back at me. So we'll be using this. So if I were to, like, unfortunately the video cable's not long enough. If I was to show the ground, you would see the white line, and you would see that you can take that white line and very easily filter it out once we have the algorithms working for that.
So that I can see.
I'm going to close the window. You still need the last line of display webcam, right?
Yeah.
Notice this, but when you close, so up here at the top, the start button is gone because the program is running. Then when I close this, the start button didn't come back. That means the program is still running. If you hit the stop button, it will stop the program no matter what. However, we shouldn't rely on that. We should make our program, we close the window, the program ends. Now what's happening here is this thread running this code doesn't stop because it says, oh, well, the webcam still is working, so it's going to keep getting frames from the webcam. It's just not going to be showing them anymore. So what we need to do is tell that thread to stop running. So this one is actually a lot less code to type. We go back to our designer, and if you can't find the designer for the form, in the Solution Explorer, if you double click on the form1.cs file, it should open this. Yes?
My computer just often is working on updates.
Well, don't worry, you'll have the video and the PowerPoint from this. So just, I guess, sit back and watch, find a buddy to work with. Because you three are a team, right? So that's teamwork. You have two computers. And that'll speed things up with typing. Okay, so click the top once just to make sure you have the form selected. In the bottom right in Properties, there's a little thing with a lightning bolt on it that says Events if you mouse over it. If you click on that, it will change the Properties window to show the events associated with the form itself. So the form is the window. We want to say when the window closes, end the program. So if we scroll through this, there's a thing that says form closed. There's another that says form closing. Either one should work. I'm going to use form closed. If you double click on it in that little box, it will open, it'll generate a function for you. That's why I said there's less typing because it makes it for you. And then it will open it in the code editor. And in here, all we have to do is take the thread and tell it to abort. So we're saying, give up on what you're doing, just stop, and so this will end that thread. So, just as a demonstration, this part is sort of extra, but it's very nice to have. Now, when I close the program, it actually closed the program. You can see at the top, the start button is back. That means the program actually finished running. Okay, so now we can move on to the actual image stuff. So, there's a type we used in that code. In this code here, we use something that says mat. Now, mat in this case is short for matrix. However, you don't have to actually know any matrix math. You don't have to take linear algebra to know how to use this. In this case, we have a lot of functions already made for us. However, this does actually represent data in a multi-dimensional array, basically. And that's all an image is. Our images are just 3D objects, basically. Yes? Okay, so back to where we were. We had that mat. Now that mat is not a horribly user-friendly type, but it is a more modern, it's the OpenCV3 type, and therefore it's the EmguCV3 type. So that's something that's just, it's a newer change. However, we can still use the image type. If you've used EmguCV, you've used the image type. It's very user-friendly. It has a lot of features that you can access. It'll be very useful for you. So this will skip through, but we can load files using this mat class, just like we could the image. We can create a new empty one. We can create one with a given size to make a blank image. But we don't have to deal with this. Yes?
Can you access this like PowerPoint?
When I will get out the actual PowerPoint file. Because if you notice, I'm not using it as a PowerPoint presentation. Because I don't run it as a presentation, so I can use the code from it. So I will be sending this actual file out. You have a question too?
You will also send out these programs, tutorial programs. You have
Yeah, we can. Okay, so we have this mat that we got from the video capture. So the video capture will only output in the mat type. We want to use an image type. So converting between the two is actually very easy. So here, and here there was another include that this needed. But here we have, I'm saying, make an image BGR byte. So it's an image that is blue, green, and red, where every color gets 1 byte to represent it. We're going to name that image. So it says IMG equals frame.toImage. And here I'm saying make it an image BGR byte. So that's, again, that's an image that has red, green, and blue, but not in that order. And then it stores each of those with 8 bits for each color.
It's asking me to simplify name byte.
Oh, you can. Yeah, byte can be uppercase or lowercase. And I'm going to make one other change here. Here we were using the frames bitmap. I'm going to get the bitmap from our image that we just made. So we'll be right back to this code, so don't worry if you missed some of that. Yes?
Would this stuff I did have saved in this?
It should. It depends. Well, did you run it and it worked?
Yeah.
Then you'll have all the code from them.
Well, how do we access that?
When you open Visual Studio, it'll
Yeah,
have
I
it as.
already opened.
It should have it as a recent project.
This is Windows Forms app, and then it says console app.
Hold on. Did you click New again? Oh, that's what you named. Wait, not that. Go recent. Click this top.
This one?
Yeah, it says that's the last thing you hit open. Okay, so that should be good. Okay, so that, as I said, it said BGR. That's for blue, green, red. We usually hear of RGB for red, green, blue. This is just a very minor variation. It changes the order the colors are stored in. So with Emgu, we have some other options. We can do Grayscale, which it refers to just gray. We have BGRA, it's red, green, and blue, but another color for transparency. We have a few other things, and then we have one that we will come back to today called HSV for hue, saturation, and value. So that said that we're using a byte to store each color. That means each color has 8 bits, 24 bits total. Now, if you haven't worked with binary before, that's okay. You don't really need to for this. But because this is a byte, 1 byte can only store up to 255. So our color range goes from 0 to 255 for each color. So that means we know what our limit is. Yes?
Can I just go ask my dad?
Yeah, go for it. So there are some things that go beyond that. We won't need that. For some advanced features, it actually uses a floating point number for each pixel in the image, which is pretty cool that it can do that, but we won't need to get into that today. So we also can convert one image type to another, or from a matrix or a mat to any image type we want. We used BGR. Here's an example that turns it into a grayscale image. And I'm going to grab this bit of code here. So here I'm making an image that stores grayscale as a byte for each pixel. And then I'm naming it image 2. Then I'm making it the value of the original image converted into grayscale. I'm going to make one other change here. Instead of image.2 bitmap, I'm using IMG2. So I'm going to leave this code up for a bit. But I just want to show, now that this is converting it to grayscale, now we have a black and white picture of myself when we run the code. And I'll get that out of the way for you guys who are still getting the last of it. Yes?
Can I see the stop line, the one where it stops? The one.
Sure. That's this line right here. That's the only thing that was in the form closed. Yes?
Can you like go up? I need to like get it from you.
Hold on a second. There's still people who are getting this section, I guess. Yes?
When you run the program, I saw the right side to show you something.
That's showing CPU usage and memory usage.
It's not from this program itself, right? Just your computer.
No, it is that program's memory usage. So it's pretty useful to see if you have like a memory leak.
But that's from
Visual Studio, yeah.
from this.
Yeah,
From that phone.
it's called the Oh, but you need to
No, I know.
Yeah, the newer version has it built in. It just automatically pops off. So I'm going to go back. Now you don't need this code. I just want to show here that it's row and then column. So it's actually Y and then X. Yes.
So is the array like a 2D array?
Yes. And in C#, there's two kinds of 2D array. There's a 2D array with two pairs of brackets, which is not necessarily rectangular. If it has a comma between the two things, that will be like a rectangle shape. So images are naturally rectangles. So we can use this to both read a pixel, so we can get a value, and we can use it to write a pixel. We can change a value. So again, you don't need this code. I'm just doing this as an example. I set one pixel to be perfectly white. It's very hard to see. You can't see it at all, actually, but
Try covering like the entire thing.
no, this is too low resolution, unfortunately, or it's too blurry, or because I can see it. Yeah, it's also it's one pixel. Hold on. Here's what I can do. Let's see if this makes it a little more visible. Oh, now you can see it. So there's a little line in the upper right corner. I just set all those pixels to be white. So you can manually change pixels in the image.
How do you change the pixels again?
You access it like it's an array.
Oh,
And you can use that for reading and for writing. However, that's the slower way to do it. Unfortunately, because that turns it into an object that gives you more information about the color, that takes a little bit of extra time. What we really would want to do is use this image.data. So each image object will have a data member. That member is a 3D array, which works the same way, but has an extra location for which channel it is. So for a grayscale image, there's only one channel, channel 0. That's just how far it is between black and white. For BGR, there's 3, one for blue, one for green, one for red. So one other thing you can do, if you treat the image like it's an array itself, you can get one channel from the image, which will be a grayscale image. So if you, here I'm treating a BGR image like an array, I'm saying get channel 0, that will get me just the blue pixels in the image. And by just the blue pixels, I mean it's the blue channel where it will take how blue every pixel is and make that the value of the pixel. So the next thing to talk about here is thresholding. This is an operation that takes all pixels above a certain level, sets them to white, and everything below there becomes black. So we're going to be using the binary threshold. There are a few variations on this. And I just have to make one change because I named my black and white image, or my grayscale image, image 2. So here I'm doing a threshold on this. The first value as input to threshold binary is the threshold value. The second is what everything above the threshold is set to. So here I'm saying set it all to a new gray with a value of 255. We said 255 is the largest value that can fit in 1 byte. So this is saying set everything to white. White will be the largest value. If I set it to 0, that would be setting it to black. However, in this case, everything that is not being set to white will be set to black. So if we set these pixels to black, it'll just blank out the whole image. So I will run this as an example. So here, I'm on a white background, so this actually works perfectly. And I wish I had a whiteboard marker because I could write something and it would show up on here. But you can see I stand out pretty well. Well, I don't really need one. I work well enough for this. So I stand out pretty well on this background, or if my shirt was a little darker, it would be perfect. But we're going to use this, instead of finding a dark object on a white background, we're going to be finding a white object on a dark background. Yes?
How do we type it in to make that?
It's this line here. So this line is converting the color image into black and white.
Okay.
This line here is taking that black and white image, setting it equal to the version of itself where everything above...
Wait, so are both of the lines on top of it, do they both work together?
Yes. So here, I'll put in some comments to help explain this. Yes.
I need help from my close control where it stops this.
Well, I'll just go over there. It's one line of code. Okay. That threshold value may not be the value that we actually want. You know, the lighting conditions can change. If the lights were on, that threshold might not work as well, because I will be a lot brighter in that case. In a darker room, everything would turn black because it would all be very dark, even though I would still stand out from the whiteboard behind me just because it's totally white. So we're going to do a quick example here. we're going to take, so I went back to the designer. I'm going to make the window a little bigger. I'm going to go to the toolbox, and I'm going to grab something called the track bar. So the track bar, I'm going to make mine a little bigger so it looks nice. The track bar is like a slider. It says, well, we have a value range. We want to pick a value within it. There is one change we need to make to the slider. Instead of events, so there's, next to the lightning bolt, there's a button that selects properties again. This brings us back to where we were, where we can change the values of things. So what we want to do is look in here. So there's a maximum and there's a minimum. It's called a track bar. That's what they call it because it's used for like media players like us. So here the maximum right now is 10. 10 would not be a good value for us. We should change that to 255. So now this, we can slide it back and forth when the program is running and get a value between 0 and 255. So now I'm going to double click on that slider to create a track bar scroll event. So this is when somebody changes the value by moving that bar, this event will run. Going to create a variable outside of this. And I'm just going to call this threshold. And when this changes, so here we can set the threshold equal to the value of that track bar. And this will make our program a lot more convenient. So that means, when we have this program running, we can slide that track bar around to try to get a value that's better for us. Now, we'll talk a little bit at the very end about things that make this a little bit easier instead of using a slider. A slider isn't the ideal way to do it, but it is a very simple way to do it.
Where does you get this value? Where do you get this value?
Yeah, you can choose a value, but it's not really adaptive. So if the lights turned on in the middle of the course, this wouldn't work because it would be programmed basically for the first part that you were looking at.
What I'm saying that you need to assign the
Yes.
value.
Oh, yeah.
Number to the value, right?
Yeah. So here it's setting the threshold to the track part. The value will be how far it is from left to right, but it's scaled, so ours is set to go from 0 to 255. Here, I'll demonstrate it. The other change that needs to be made, this threshold, right now it has a value of 100 as a fixed value. I'm changing that to the value we got from our slider. Now, you might wonder, why didn't I just put trackbar1.value in there? That causes an exception to be thrown because we're doing it on a different thread. It's just best to do it this way. This would also allow us to add other ways to change the threshold that could be a little more flexible. So I'm going to run this. Now, right now, the whole thing is white because everything is greater than the threshold. The threshold is set to 0. As I move this up, you can see I become visible, and then suddenly nothing is visible. But having this slider is very convenient because you can find a good position that might, let's say I was the backdrop of the line. Well, now I'm all black on here, so it's cut me out of the image. So the next thing to talk about is counting white pixels. To follow a line, you need to have knowledge of how many white pixels are in view of the robot. You'll have to also know where they are in the image. So to count white pixels in general, you could do a double for loop. One for loop for rows, one for columns. Look at each position. If that pixel is equal to 255, add 1 to the counter. Now that is actually more work than we need to do for this. There's a way to do it with a function that's built into EmguCV. One line of code to get the number of white pixels in an image. And this is actually slightly faster as well, or it should be. So here we have, if our image is already thresholded, so everything is either 0 or 255. Here, this image that count non-zero, that will give us the number of white pixels in each channel of the image. So we have to say, in square brackets after it, 0, because there's just the gray channel. That's how bright each pixel is. This will do it. This will count up how many white pixels there are. So I'm just going to, you don't need this part. Well, you might want it. But what I'm going to do here, just as an example,
Image 2. Image 2.
oh, thank you, good call. So now this says 83,524. That is the whole area of this image. If I start lowering this, now it says 25,000. I go all the way, now it says 0. So this little one line of code here counts up all the white pixels in the image. But again, you can do a loop, and that only works because we're looking for white pixels. If we were looking for some other color, we may need to make our loop work differently. If we wanted to look for something else in our image, well, unless it's thresholded, the count non-zero will not work. Or it won't do what we want. It only separates black and everything else. So this is a side note. You can also add labels to your program. So labels are, this is Windows form speak for text. So this isn't necessary, but this is a little example. The label in the toolbox here, I drag this in. So I'm going to leave this how it is right now. You can change the font, you can change the font size, and you can change what it says by default. So you could use this to add something to be more descriptive about what something in your program does. Yes?
Is this presentation like sent?
Sorry, what was it?
Is this presentation sent to our parents?
It will be, yes. Yes, you will have access to it. That's why I feel okay going a little fast, because you can always catch back up. Okay, so back to where we were. I added that label just as an example. So if I tried to set the text of that label, and when you have a label like that, if you do the label's name dot text, you can set or get the text that is being displayed on that label. So in our case, I'm going to change this to show the white count. So I had to do this extra bit of code. This is in the presentation just as an example to help you. Where now if I run this, the number shows up in my user interface. But if I did not have that extra bit of code that says invoke and those extra steps, it would throw an exception instead of that.
Sorry.
Oh,
They have a headline.
okay. Like I said, you're welcome. Have fun with the robots. All right, so the next thing to talk about is our actual line following. So we're finally getting to the practical part of this, because we've looked at an image, we can find how many white pixels are in it, but how do we actually make a robot move based on that? So, just real quick, I just want to talk about how line following works in a lot of versions. We have the first version, which you may have done before with a Lego robot with one sensor. If you have one light sensor, you can zigzag along one side of the line. When the robot is on the line, it goes forward and to the right. When it's off of the line, it goes forward and to the left. This causes it to zigzag along the side of the line. They can do this very effectively. With some more advanced versions of it, it can actually stay pretty close to that edge of the line and follow it very smoothly. There's another variation using two sensors. So the one sensor line following has some issues where there's some structures you could make that cause it to lose track of the line and just turn around or start spinning. With two sensors, it's a little bit easier to stay on the line. You can actually center yourself on the line and you zigzag to keep on top of it rather than trying to stay right on the edge. Then there's some sensors available. I believe there's one of these for Lego available that has more line following sensors. Just a bunch of light sensors put together, and you get a position for the line underneath all of them. This is even more useful, but it still has some limits. We can only see those sensors and what's directly beneath them. There's still a limited number of sensors, and it doesn't handle paths where there's a big gap in the path or some branching part of the path very well. But this works even better, or it's a little bit easier to work with. And it has more sensors. But what has even more sensors than that and can see it ahead of it? A camera. The camera is like a whole bunch of light sensors, except they're set up so they can see forward instead of just directly beneath them. They can see far enough ahead of itself so that it can predict branches, so that if there's a gap, it can see where the line goes after the gap. And it has a much better resolution than any set of line sensors ever will. However, it requires a computer to actually handle it. The other ones worked with Lego pretty well. They worked with, so you could do it without any processor at all. There were a lot of early robots that were like those two sensors that ran without any processor. They were just some wires put together just right, the correct components to handle it all automatically. But for line following with vision, that isn't possible. So we're talking about the two sensor approach, where there's a sensor on the left, sensor on the right. If you see that the line is on the left, turn to the left, line on the right, turn to the right. We do the same thing with vision. We take thirds of the image, we see, oh, is the line in the left third of the image? Turn to the left direction. Line on the right third of the image, turn to the right direction. Otherwise, go forward. So our L2bots are very limited in how they can steer. They can only really turn left or turn right. They can go forward and backward as well, but they can't control, like, oh, turn at 20 degrees per second. You know, they're not that precise. But they're good enough for something like this. They can follow a line pretty well like that. So here's an example for using two for loops to find the left third of an image, find the number of white pixels in it. However, we already discussed that there's an easier way to find white pixels in an image. So here's a version that finds all 3/3. So we're setting something, this image.ROI. The ROI is for region of interest. This is saying what part of the image we actually want to work with. So here we can actually take this, and I'm going to put this in Visual Studio. So that so the region of interest is creating a rectangle. This rectangle is saying, oh, well, I want something that starts, the first one, top left corner, that's 0 in the x direction, 0 in the y. It's saying its width is 1/3 of the image, its height is the height of the image. Second part, start at 1/3 of the way through the image at the top. Width is 1/3 of the image, go the whole height of the image. The right section, start at 2/3 of the way through the image and get the last third. So this code here will count the number of white pixels in each section of the image. So this is code that you may want to use here, because this will be very helpful for following a line. So we'll keep moving forward here so that you can get to moving the robot. We can come back to that code if you need it. So there's other ways that you can do line following with vision. However, the L2bots are not really good for much more than the way we talked about today, just steer towards the line. More precise robots can handle it a lot better. We had a very cool approach we used for a demo in the new building, but unfortunately the L2bots can't quite handle as well as our IGBC robots were able to. There's some other ways, if you can find the actual lines in the image, that you can do even more. Another note, so next up is actually moving the robots. So we'll actually hand out the robots for that. The threshold, we were using one that you set with that slider. However, it may be better to use something based on the average value of a pixel in that image. If you look at the white line on the ground, well, the white line is significantly brighter than everything else on the ground, because we're using a dark floor here. It's dark gray. The competition will use a dark matte. What you'll actually be able to do here is say there's two types of pixel really here. There's things that are the ground, which are dark, and things that are the line, which are bright. So if we thought about how these would be distributed, there's a line we can draw in between them, where we say everything darker than this value is going to be the ground, everything lighter is going to be the line. That's the threshold we want. Well, if there's two peaks here, the middle might just be the average. So there's variations on the average you can do in order to attempt to get a threshold that sets itself automatically. That's something for you to experiment, for your team to be able to perform better at the competition. So now we're going to talk about getting the L2bots moving. So we have serial communication to talk with a microcontroller. In C#, we handle this through the serial port class. The serial port class is able to do reading and writing through a serial port, and the L2bots communicate over a serial port. Our laptops, none of your laptops probably have a serial port on them, because this is 2018, not 1998. So we have a USB to serial adapter. And you'll be able to just plug this in, and then your computer will be able to communicate with the L2bot just like if it had a serial port on it. So there are two parts to this code. And again, we can come back to any part of this you need. The first part here is the part that defines a serial port. And actually both parts of this go together. This part here, so I'm going to start putting these in the project file. This is creating the serial port. It takes two inputs. One is the name of the port, in this case COM4. When you have your serial connector plugged in, you will get you'll get a name for that. It might not be COM4, it might be COM3, it might be something else. It depends on what USB port you plugged into and what else you have plugged in at the time. The other part of this is the baud rate. That's how fast it's talking. It just has to be compatible with it. Unfortunately, we can't just increase the speed. That would be cool if it worked that way. The L2bot, the motor controller on it, expects this speed. So most of these settings you will not be able to change, or all but the name of the port itself. So the part defining the serial port will go outside of any function, because this has to be used in the display webcam section to tell the L2bot what to do, but it needs to be set up before that. We have some other settings for this that we need to set. These are things that tell it how to communicate with the L2bot. These are things that are basically set in stone. We can't change them without having to reprogram the L2bot's motor controller. So I'm going to put those in the Form 1 load. And actually, I'm going to put them at the beginning. So the last part here, and don't worry about typing this all in right now. We'll come back to any part of this you need. The last part here opens the serial port. So just like with the thread, at the very end, in the form closed event, we would want to add something to tell it to end communications over that port so that it doesn't leave the program open again. So we have a method called write to send an array of bytes over the serial port. Before we talk more about that, the motor controllers we've been using with these L2bots are called a Loco-Moco, or low-cost motor controller. It has a chip on it called an H-bridge, which basically is some transistors together so that you can select a direction for each motor to use. I guess specifically I should say this is a dual H-bridge circuit. It's very nice for us to have, it's very reliable. These have been a great platform for us to use. So they have 4 commands that can be sent to them. We have stop, float, forward, and backward. So you may have noticed that there's no turn left or turn right. These commands are for each motor. So if you want to turn left, you would say left wheel stop or left wheel backward, right wheel forward. So you can't just tell it turn right or turn left. You have to tell each wheel what to do.
What do those numbers stand for?
That's a good question. These numbers are just the commands that were defined for how this will work. Unfortunately, this only accepts these different commands. There's no extra ones, and they're sort of arbitrary. They're just what the developer chose to use. So when we want to tell the motor controller what to do, we will use 2 commands here, one for the left motor, one for the right. This code is another thing that you don't really get to change. You'll change what the commands are for left and right. This part here will almost always be the same, because you're just sending one command. It has to have this structure, and that will send it to the motor controller to tell it what to do. So we'll come back to that. I just want to cover one thing real quick before we move on to letting you practice with this line. We have another challenge involved in the competition, detecting what color a sheet of paper is. We will want to use something called HSV for this. So we know about RGB color. You may not have heard of HSV color. If you played around in Photoshop, you may have seen it, or you may have seen its cousin, HSL. They're very similar, same concept. Instead of making color the way the computer actually displays it in the hardware, because RGB is for the red, green, and blue light that it uses to display something. We don't think in red, green, and blue. We think in terms like this. HSV, the H is for hue, what color. So this actually is done as a circle. The hue is actually the angle on the circle. So I should say the whole system is a cylinder, like this illustration here. There's a slice taken out of that. Really, it would go through there, through everything. Yes?
How can it be a whole circle if it's only 180?
That's a good question. Do you remember how I said a byte can only store up to 255? Well, a circle would be 360, right? Well, that's too big for it to store in 1 byte. So the people who made this software divided it by 2. So it's only half of a circle in actual like numbers, but it's just you have to multiply it by 2 to get the real angle. Yes, that is a good question. And then we have saturation, how intense the color is between white and just pure whatever color. And then we have value, which is how bright it is, which goes from black. It goes basically from black to white. Then those two are from 0 to 255. So we can, just like we converted an image to grayscale, we can also convert an image to hue, saturation, and value color. And then we can access the pixels in it the same way we could access the pixels in the BGR image, or the grayscale image, just like it's an array. So this allows us to get information about a pixel not just as an intensity value or in RGB. This will tell us what color it is, how bright that color is, and how intense that color is. So there's a little bit of example code, and again, this will be passed out to you later on. So you won't need to deal with detecting a red object today, but in the actual event, you'll need to detect objects or sheets of paper of multiple colors. So if you have an HSV image, there's a method that's very useful called inRange. So I'm just going to make a quick demonstration. So I had an example here that uses this function with the count non-zero to count white pixels. This inRange function takes 2 colors as input and returns an image where it's white, where the the pixels were in between that range. So here I'm saying between 0 and 255. And CJ, can you hand me something? You have something red in there? Well, actually that will work.
Oh,
I was going to say the box
I
itself.
actually have CJ, I actually have very good red paper thing.
Oh, not.
In my box. Yeah, that big one. Yeah. At the bottom.
Oh, great.
Okay, that'll work.
Yeah.
Oh, yeah, perfect.
Perfect one, yeah.
Yeah, okay. So hopefully this is on the right side of it. Here, hopefully it sees this. It might not be. Okay, well, it's sort of working. It might just be too dark in here. I'm going to lower the brightness requirement. Oh, that worked better. So now all that's showing up in this image is where this red paper is. Yeah, I'm not really showing up. Some of my skin is showing up a little bit. I actually think those are my lips that are showing up at the top, because those are actually red. But everything else in here is just the red sheet of paper. Now we'd have to play around with this. Again, the lighting in here is poor, but it's cut this out very nicely. At the very least, it's not showing anything else. And when I hold something of a different color in front of it, it blocks it out. So this HSV color processing is very powerful for this challenge, because what matters is the color you see, and all the colors will be very saturated like this. So that means with HSV, you can very easily find the targets you're looking for. again, I combined this example with that count non-zero function so that we could see how many pixels were white in the image, which were the number of pixels that were red. So if I had used this, I could count how many red pixels are in the image, make the robot do something based on that. Red is a important example here. Red is at the very end of this little color wheel. So we had this little circle. Red is at 0, but you know it's a circle, so you know it's also at 360. Well, that means we have an issue where, in our case, it's at 180, but that means the color at 180 and the color at 0 are the same. So to look for red, you may have to look at both sides. Look at how many pixels are between 0 and, say, 20, how many are between 160 and 180. It also depends on the shade of red. If it's bright enough red, and it's red enough red, or more of an orangey red than a purpley red, you should be good. Okay, so the rest of that I'll leave as a bonus when you check out the PowerPoint. If you would like, so we have some time here for you to try to follow these lines if you want. Once you have this code for detecting how many pixels are on the left, how many are in the center, how many are on the right, you can compare those values. So we discussed if there's more white pixels on the left than on the right, you'll want to steer towards the left. Now, there's variations on that. I said more on the left than on the right. You may want to check, are there more on the left than in the center and the right? They're more on the left than some amount times the number in the center. There are a lot of variations you can do to make this perform better.
Shouldn't it, for the center, shouldn't it go from image width over 3, 0 to image width over 3 times 2?
That's a good question. The third parameter there is width, not a second x.
But shouldn't it go to times 2?
Okay, exactly. The width is just the center third, right? Yeah. And let me... And then I can go back to the code for moving the L2bot as well. Since I know we went through all that part a bit quicker. But if there's any code you want to see or any questions you have, we can cover those. CJ, are these L2 bots for them to
Yes,
take?
they are ready.
Okay, so
Excellent.